All right, so again, you should not be doing grouping when this is a 1x squared. You need to just think about what can I FOIL out that would give me this back again, okay? One more thing I wanted to mention too, both of these are quadratic equations, right? This one looks more like standard form. This one looks a little more like vertex form. How you solve them is different, right? We can't forget this stuff from the first half of the chapter. The first one we can solve by factoring. So you just think to yourself, x times x gives me x squared. Whatever goes here times here, remember, has to multiply to 16 and at the same time add to negative 10. So you just start thinking about the things that multiply to 16. Both are going to have to be negative, right? So maybe it's negative 1 times negative 16. Maybe negative 2 times negative 8. I'm going to stop right there because that is the pair. Negative 2 times negative 8, right? FOIL it out and check it. X times x is x squared. Outer gives me negative 8x. Inner gives me negative 2x. Last give me positive 16. And guess what? Negative 8 minus 2 is negative 10. Like, it works. So we have to tell the solution still, right? The values of x that make it equal to 0. So again, you can write like, how can I get this factor to equal 0? How can I get this factor to equal 0? And you probably already know the answers, but if not, remember you just solve this by adding 2. So x equals 2 should be one solution because plug it in. 2 minus 2 is 0. Our other solution, add 8 to both sides to solve this. We're going to get x equals 8. Again, it makes sense if you plug it in because 8 minus 8 is 0. So when we had problems like this second one, remember we could just use square roots to solve it. So basically work backwards, and at some point you're going to be taking the square root. Start with addition or subtraction. So take away 5 from both sides. 77 minus 5 is going to give us 72. Divide by that 2 to get it to cancel, because 2 divided by 2 is 1, right? Make sure we do the same thing on the other side. Then this is the point where we take the square root. Don't forget, whenever you take the square root, it cancels the square, right? But we got to think about the square root of 36 could be 6 or negative 6, because negative 6 times negative 6 also equals 36, right? So then you take away 5 from both sides to get x alone. Now remember, I would instead of writing plus or minus 6, positive or negative 6 minus 5, I would put the negative 5 first, and then just read this from left to right. Negative 5 plus 6 is going to give us one answer. That's going to be positive 1. Negative 5 minus 6 is going to give us the other answer. That's going to be negative 11. Okay? Moving on to the next section here. Today we're going to be talking about complex numbers, so I have a question to ask you first. If I said to you x squared equals 16, what would have to be the value of x? What number can you square and get 16? Brenna? 4 works. Yep. Emerson, were you going to say the same thing or something different? Right. It could also be negative 4, right? Because negative 4 times negative 4 is also 16. What if I asked you what number can you square and get negative 16? Let's go back to this for a second. 4 times 4 is 16, so is negative 4 times negative 4. So there's nothing you can multiply by itself that would give you negative 16, because all of the things times themselves give you positive 16, right? So previously in Algebra 1, like if you try to take the square root of negative 16, your calculator would tell you that that's an error, because again, there's nothing times itself that gives you negative 16, okay? So now that you're in Algebra 2, though, you're going to learn that the answer to this is an imaginary number, okay? So first, we're going to define, again, if we try to solve this, if we try to take the square root of negative 1, you can punch it in your calculator. It's going to give you an error, because 1 times 1 is 1, so is negative 1 times negative 1. There's nothing you can do times itself that would give you negative 1, Okay, so again, previously we've said the square root of -1 doesn't exist. So we're going to define imaginary numbers today. So I want you to write this down in your notes. I is how we define the square root of -1. It's basically just we're giving the square root of -1 a letter to represent it, is essentially what it means. Okay. So then I want you to think about this for a second. I squared, like if I square this, I'd have to square this side too, but the square root cancels the square, which means I squared will just be -1. Okay, again, previously we had no number that when you square it equals -1. But now we say that I does. When you square I, you get -1, since I is defined as the square root of -1. Okay, so again, two important things to make sure you have down in your notes: that I is defined as the square root of -1, which means I squared equals -1. Make sure you have both of those things written down in your notes. So a little bit of review here. Do you remember the product property? How when let me give it to you with numbers. If we had like 9 times 5, we split it apart because 9's a perfect square, so we could just write it as 3 radical 5, right? We've already learned that. We're going to be using that property when we have the square root of a negative number, because what we can do is rewrite -16 as 16 times -1, and then we can use our property and split it apart. And then look, because the square root of 16 is just 4, and the square root of -1 is defined as I, we would say that the answer to this is 4I. Okay? I'll give you a minute in case you're writing that down. All right, so let's look at some examples. Let's start with the square root of -9. Again, previously in Algebra 1, we'd say no solution to that. But now we've learned that if we write this as 9 times -1, so that we can use our property and split it apart, just like we did earlier in the chapter, the square root of 9 is just 3, and then the square root of -1, that's our definition for today. We call it I. So the answer will be 3I. Okay, let's try another one. So again, anytime you have the square root of a negative number, you're automatically going to rewrite it as +3 times -1. And then you're going to use the property to split it apart, because of the fact that the square root of -1 is defined as I. And then the square root of, back on this one, this was a perfect square, right? The square root of 3 is an ugly decimal, and we can't simplify it at all. So we just leave it as radical 3. Now, one thing, guys, this one is fine the way that we wrote it. We don't want this to get confused with like people thinking the I is under the square root, because it's not. So a lot of times this is multiplication. The order doesn't really matter. A lot of times we just put the I in front so that there's no confusion, that no one will look at your answer and think that, or you won't, like, you might accidentally on Edulastic type this is the answer, which would be wrong, because the root is only supposed to be over the 3, not the I. So that there's no confusion, we usually just write the I first. What's up? Yeah, that's literally the definition of what the square root of -1 is. We call it I. That's the variable that we use in math to always represent the square root of -1. Other questions so far? Okay, let's look at solving an equation. So this doesn't look too different than some of the stuff you just had on your quiz yesterday. So when we start to solve this for x, we're just going to work backwards till x is alone, same as we've previously done. So let's go ahead and take away 11 on both sides as our first step, because 11 minus 11 is 0, right? That'll just leave me with 2x squared over here. -37 minus 11 is going to give us -48. Opposite of multiplication, let's get rid of the 2 because 2 divided by 2 is 1, right? So we're going to just have x squared. Negative 48 divided by 2, negative 24. Again, if this were algebra 1 and we tried to take the square root, we would say no solution. But now that we've defined an imaginary number in algebra 2, first of all, you're still going to put positive or negative every time you take the square root. Let's think off to the side about the square root of negative 24 for a second. First of all, remember we said we're always going to write it as positive 24 times negative 1 because we know that the square root of negative 1 is defined as I. So we can go ahead and split it up right away and change the negative 1 in a second to I. But I want you to think about the square root of 24. It doesn't come out whole, right? You can punch it in your calculator if you don't remember. It's going to be a decimal, but there might be a perfect square in it. Like we have to think about what we learned in the first half of the chapter. So hopefully you know pretty quickly that 4 is a perfect square that goes into 24. We're going to rewrite that as 4 times 6. I'm going to go ahead and change square root of negative 1 to the I, okay? We can still split this part up. So square root of 4 is just 2, right? So, this is one big product. Technically, the order of multiplication doesn't matter. But just like I told you on last one, if we were to type this on Edulastic, some of us might accidentally have the I under the root, and we don't want that. So normally we often just rearrange the order and put the root last if there's a root in our answer, okay? Like we had some of them where there was no more root, like here, then you can just write 3i. But if there's a root in it, still we oftentimes write the root part last. So the answer is positive or negative 2i radical 6. Questions so far? We're going to try another one that's like the exact same steps. So hopefully you took good notes on this one because I'm going to give you a chance to try this one on your own now. So first thing we would want to do is add 7 to both sides because negative 7 plus 7 is 0, right? Negative 31 plus 7 is going to give us negative 24. Then we want to divide by 3 because 3 divided by 3 gives us 1x squared, right? Negative 24 divided by 3, negative 8. You're going to take the square root to finish it. Again, if this were algebra 1, you would have said no solution. You would have stopped whenever you saw the square root of a negative number. But now that we're in algebra 2, we can keep going. The square root, first of all, is going to have 2 solutions, a positive and negative. Let's think about square root of negative 8 off to the side here. Again, always write it as the whole number times negative 1 because you're going to split it apart because the square root of negative 1 is just I, okay? But then also square root of 8 has a perfect square in it. So you're going to rewrite it as radical 4 times radical 2 so that you can take the square root of 4. It's just 2, right? When you write your final answer, again, mostly because we don't want to get confused and think the I is under the square root. We're going to rearrange the order and do 2, then times I, then times radical 2. And don't forget the positive or negative sign in there, okay? All right, questions on that one at all? Okay, we're going to have another definition on this next slide. A complex number, you're going to want to write this part down. Don't worry about the chart. Just complex number is a number that has a real part and an imaginary part. So you can look at some examples in the chart, like 2 plus 3i, for example. So 2 is a real number, right? Like that's on our number line that you've been studying your whole life. But 3i, if it has an I in it, it's imaginary. Like that means 3 times the square root of negative 1. So a complex number is going to have a real part and an imaginary part. So just like you can add real numbers, like I can add 2 plus 3, right? It equals 5. Well, you can also add complex numbers. Like these are two examples of different complex numbers. You can add those together. You can subtract them. You can multiply them. You can divide them. You can do all the operations with complex numbers that you can do with real numbers, okay? That's what we're going to be getting into next, just operations with complex numbers. Does everyone have the definition of complex number down here? Again, we don't need to sit here and copy the whole chart down. Just make sure you have that part. Anybody need this slide still? All right. So if you're going to add and subtract complex numbers, basically you're just going to add the real parts together and you're going to add the imaginary parts together, okay? So look, this is a complex number plus another complex number. Go ahead and copy this question down into your notes. So in order to combine them, we're going to have to sort of get rid of the parentheses first. Guys, I want you to imagine this is like a 1 here, and if I do 1 times anything, it doesn't change, right? So the parentheses essentially are that we don't even need them to be there. We can kind of just drop them. Same thing here. If I multiply by 1 to everything, it doesn't change it. So really, when it's addition, you can essentially just drop all the parentheses. And then what we're going to do is, again, combine the real parts, which would mean 6 plus 2. So that's just going to be 8. And then combine the imaginary parts. So positive 5 minus 4 is positive 1i. It's just like doing 5x minus 4x is 1x, right? It's the same idea. It's just like adding variables. 5 minus 4, you have 1i. So we're just going to write plus 1i. We don't really need to write the 1, though, right? If we just write I, it means 1i. Just like when we write x, it means 1x. So that's our answer for the first one. That's how you add complex numbers, okay? Just add the real parts, add the imaginary parts. Let's look at subtraction. Go ahead and copy this down. So it's saying take this complex number minus this complex number. The only thing that's different about subtraction is this is still like a 1 here. So basically we can just remove the parentheses in the first quantity because 1 times 2 is still 2. 1 times 3i is still 3i. But subtraction's the same as addition of the opposite. So like we need to be thinking of this as a negative 1 times 7 and negative 1 times negative 4, which is positive 4i. Like the signs are going to change in that second quantity when you're subtracting, because that's what subtraction is. It's like adding the opposite of everything. So the 7 becomes negative 7. The negative 4 becomes positive 4i. And then it's just the same as the last one. Just combine the real parts. So 2 minus 7 is negative 5. And combine the imaginary parts. 3i plus 4i is positive 7i. Okay. Now, you're always going to write it. Remember back on this slide, we said like the definition of a complex number, A is the real part, BI is the imaginary part. You're always going to write it in that order. Like technically this has the same value if I switched the order, right? But what's called standard form is writing the real part first, then the imaginary part. We're always going to write it in that order, okay? I'm going to give you a minute to practice one addition problem and one subtraction problem on your own, just to see if you're understanding what we did in the last example together. So again, with addition, because this is just like 1 times 8 and negative 1i, and then 1 times 5 and 1 times 4i, basically you can just drop the parentheses and then combine the real parts. 8 plus 5 is 13, and then combine the imaginary parts. Negative 1 plus 4 is positive 3. So 13 plus 3i would be our answer for that. Again, make sure you write the real part first, then the part with I, the imaginary part. Again, over here, 1 times 7 is still 7. 1 times -6 is -6. But when this is a minus sign, in order to get rid of the parentheses, it's like distributing -1 times 3. It's going to turn into -3. -1 times -6 makes that positive 6i. Combine your real parts. 7 minus 3 is 4. And then we have -6i plus 6i. That's 0. We're not going to write plus 0i because 0 times anything is 0. Like, this answer ends up just being a real number. There is no imaginary part. Okay? Questions on that? So just like you can add and subtract complex numbers, we're also going to learn how to multiply and divide them. So go ahead and copy this down onto your notes. Now, what this looks like is it's a number with only an imaginary part times one that has a real and imaginary. This one will be a little bit harder because both numbers have both parts. Like, you're going to have to FOIL on part B, okay? So listen, 4i times -6, just think of it as 4 times -6, sorry, -24, but then times I. When you do 4i times 1i, 4 times 1 is 4, and then I times I is I squared. Just like when you do x times x, and that's x squared, right? So then here's the thing, though. Remember what we wrote back on our notes, like at the very beginning of class, that I equals the square root of -1, which means I squared just equals -1. If you did not write that in your notes, you've got to write that down. It's on the board here too for us to keep in mind all the time, because anytime you see an I squared, you're just going to change it to a -1. This means multiplication, right? So either put a dot or write the -1 in parentheses. So that just is like we're doing 4 times -1, which is -4. Now remember, standard form means we need to write the real part first. So the -4 needs to come first, then the imaginary part. So -24i. Questions on that one? So we're going to FOIL out the next one. So first, 9 times -4, -36. Outer, 9 times 7i. 9 times 7 is 63, so it would be 63i. Inner, -2i times -4 would be positive 8i. And then last, -2 times the 7 is -14, but it's also I times I. So once again, I squared, which in a minute we're going to change that to be -1. Okay, anytime you see I squared. So let's go ahead and combine these imaginary parts. 63i plus 8i is going to give us positive 71i. We're going to change this to be -14 times -1. So if you want, you could go just straight to writing positive 14. I will always show every step when I'm teaching it, okay? You might not have to show quite as many steps as me. So now we have some real parts to combine. -36 plus 14 is going to give us -22. We write the real part first, then the imaginary part. So -22 plus 71i. Questions on that at all? Okay, I'm going to let you practice one. So we're multiplying, right? If there's no symbol, one complex number times another complex number. And in this case, that means we have to teaching something. So first, 3 times 3 is 9. Outer, 3 times -4i is -12i. Inner, positive 4i times 3 is positive 12i. Last, 4i times -4i. The 4 times the -4 is -16. The I times the I is I squared. So next step, we're going to have 9. -12i plus 12i is 0. The imaginary parts are going to cancel, and we can change I squared always to -1. -16 times -1 is positive 16. The answer ends up just being a real number, 25. So guys, if you look back at the question, see how these were the same exact thing except one had a plus sign and one had a minus? Those are called complex conjugates. When you multiply, we had the word conjugate earlier in the chapter when we had like 4 plus radical 7 and 4 minus radical 7, right? Remember how when we multiplied them, the radicals canceled out? Well, it's the same idea here. When you multiply complex conjugates, you're going to always end up with just a real number. We're going to use that concept when we have to divide complex numbers, okay? So you don't really need to write all this down. If you want to write down what complex conjugates are, it just means if you have a plus bi, then a minus bi is the complex conjugate, okay? So if you had a problem that was like 2i divided by 1 minus 4i, the process for dividing complex numbers is that you're going to multiply by the conjugate. So 1 plus 4i in the denominator and the numerator. Again, this should look very similar to what we did when it was like 1 plus radical 7, how we multiplied by 1 minus radical 7. It's the same idea. So then up in the numerator, you're going to have to do 2i times 1. So that's 2i. 2i times 4i is positive 8i squared, right? Because it's 2 times 4 and I times I. Down in the denominator, this is FOIL, right? 1 times 1 is going to give us 1. Outer, 1 times 4i is positive 4i. Inner, negative 4i times 1 is negative 4i. And last, negative 4i times positive 4i. So again, think of it in parts. Negative 4 times positive 4 is negative 16. I times I is I squared. We're going to have quite a bit of simplifying to do now. So anytime you see I squared, we're going to change that to negative 1. So this is like 8 times negative 1. If you want to just go ahead and write negative 8 right away, go ahead. In your denominator, 4i minus 4i is 0. And then again, change the I squared to negative 1. So that means it's really 2i minus 8, right? Because it's 8 times negative 1. And then 1 plus 16, since it's negative 16 times negative 1. So we're going to have 2i minus 8 over 1 plus 16 is 17. Are you with me so far? Questions? Okay, now keep in mind the directions said write your answer in standard form. Remember what standard form is? A plus bi, like it just means write the real part first, write the imaginary part next. So guys, what we have to do is these two terms, the real part and the imaginary part, they both need to get divided by 17. Go ahead and do 2 divided by 17 on your calculator. Not a nice number. We're not going to write that ugly decimal. Math bracket. You're just going to leave it as 2/17. I. Like if that came out a whole number like 2, we'd just write 2i, right? It's just that it's not whole. It's a fraction. You got to do negative 8 divided by 17 too. Same thing. Like that's a gross number, gross decimal. You're just going to leave it as negative 8 over 17. So our previous answers, like look back to this one for a second. It was nice because these were integers. They weren't fractions, right? This is the same. It's the same thing. It's just that your answer, your like this, the A, the real part is negative 8 over 17, right? Because we just have to flip it around. The real part's supposed to come first, and then the imaginary part, 2/17 I. So it's like A is negative 8 over 17, B is 2 over 17. It's just a fraction instead of a whole number. So that's our final answer. I know that was a lot. Well, wait a second. I think I have a copying. Do I have a copying error? Oh, no, I'm looking at the wrong thing on my paper, I guess. Okay. Questions on that at all? Okay, we're going to do another one. Again, I know that probably felt like a lot. So we're going to have here, how do you divide complex numbers? The process is that you multiply by the conjugate. Okay, 5 minus 9i, both to the numerator and denominator. So again, now this is 2 terms times 2 terms. So -1 times 5, you're going to have to do its FOIL, -5. Outer, -1 times -9i is positive 9i. Inner, -6i times 5 is -30i. And then last, -6i times -i. Think about it in pieces. The -6 times the -9 is positive 54. I times I is I squared. We're going to have to FOIL in the denominator too. First, 5 times 5 is 25. Outer, 5 times -9i is -45i. Inner, 9 times 5 is positive 45i. Last, 9i times -9i. Again, the 9 times the -9 is -81. The I times the I is I squared. Do you have any questions just on the FOILing part at all? Okay, so then, again, let's simplify a little bit. We can combine these. 9 minus 30 is -21i. And then I can rewrite I squared, make it -1 every time. Down in the denominator, rewrite your 25. -45 plus 45 is 0. There's no more i's. We write minus 81. Again, I squared is -1. So then that means we could just write 54 times -1 is just -54. Down here, -81 times -1 is just positive 81. So that means, go ahead and combine these real parts. -5 minus 54 is -59. And then have your imaginary part. 25 plus 81 is 106. Yeah. Because I made a copying error. Thank you. This changed. Look at that. Did anyone else notice that? I just forgot the one when I copied it. Thank you so much for pointing that out, Emerson. Okay, so now remember, our final answer is always going to be in standard form. A plus BI, the real part plus the imaginary part. So like we have to actually do -59 divided by 106. Punch it in your calculator. It's a gross decimal. You're just going to math frac it, and it's going to go right back to -59 over 106 because it can't be simplified. Okay, same thing, -21 divided by 106. Divide it in your calculator, math frac it. It's going to go right back to -21 over 6. But that part's with the I. That's the imaginary part. Okay, so that one will be your final answer for that one. Questions on that at all?